Alright, there is a day 3 and a day 4 to 2 of you remaining. The seniors have been released for the rest of the year. So I'm going to make one video for the week, and this should finish up everything for both days. So use this video for both days. You can spread your work out if you want to over the next Monday and Wednesday, or you can watch it all, do it all Monday. That's great too. Okay, so we're going to start with example 7. And here's what I want to get out of example 7. I'm no longer going to read these. You can all, we've seen these problems before. But the one thing I want to point out to you is when there's a partition, it changes a picture that maybe would look like this to then one that looks like this. Okay? And if you read your clues, A is 3B. C is 2A. Find not A and. So to form a partition, and it wants us to figure out not A, which would be all of this region, and B, which would be only this region. And so the overlap, since it's an AND problem, is going to be right here in this checkerboard. Okay, so if we can figure out, well, A plus B plus C must be 100, and A equals 3B, and then the last part is 2A. Get kind of stuck because there's an A there, but we can then turn A into 3B, and your new formula would be 3B plus B plus 6B, or 10. And there's our answer. Example 8 says that each Tuesday a student attends chess club with a probability of 0.6. Skips math, so like let's say math was M, not math, or skips math could be with a complement symbol. And the last one is both. Alright, so let's see here. Let's say this is chess, this is math. It says that the both, which we always want to start here in the middle, is 0.5, which means that this circle, while being 0.6, if 0.5 is already in it, we need to subtract that out so that now together they form 0.6. And then over here it says M. Well, we don't know M, so we're going to have to figure out a complement here. So if this whole thing's supposed to be 0.7, this part has to be 0.2. And so far I have 0.1, 0.5, 0.2, and to reach 100% I would be missing 0.2. That's going to go in our margin. And that can be doesn't go to either, does not go to chess, does not go to math. And then the question says, find the probability that it attends at least one club. That would be 1 or both. So you could say 0.1 plus 0.5 plus 0.2. So this would be the case where you go to only chess, only math, or you went to both of them. 1 or both. And so your answer is 0.8. As I go through this next example, I'm going to highlight what they say in the problem, and then I'm going to write it in a way that uses symbols. It says a computer which sometimes malfunctions has good sound with probability of 0.7. Clear picture with probability 0.5. And good color with a probability of 0.6. Here's the next one, both good sound and clear picture with a probability of 0.4. And the next one. And the last two. Looking at the question, it might be easier if we draw a picture. And go ahead and put 0.3 there in the middle. Remember, that's the one that's shared between all three. Okay, we've used that one. Going backwards, we can figure out P and C. So that's here. And it's supposed to be 0.4, so I need 0.1 to make that true. S and C, it's right here. Needs to be 0.5, so I need 0.2 to make that true. And the last one's 0.4 again, so I need 0.1 to make that true. Done, done, done. The whole circles, 0.6 in this one, so I have 3, 4, 5, 6, so I don't need any extra to make that true. The red one should be 5, 3, 4, 5, so 0 again makes that true. And 7, 3, 4, 5, 6. So I need an additional 0.1 to make the blue one true. And so that's everything inside the circles. Now, the part that I need is in the question. It says the probability that the television set has only one. So that's either going to be only S, which we said was 0.1, only color, which we said was 0, or, so plus, only picture, which was 0. So the probability of this outcome is 0.1. Suppose that events A and B or C form a partition. That is to say that they don't share anything, similar to the problem before, only this time A and B or C form the partition, so there's nothing shared between there. Okay, and it says that B or C is 70 altogether. Okay, that's too much. I need a more specific region like this here in the middle. B is 49 on its own. C is 37 on its own. 37. So I want to bring you back to this formula we used last week, which was the probability of, let's use B and C here, is the sum of each one individually minus their overlap. And from the problem, we know that separately these are 49, 37, I don't know that part, and then B or C together should be 70. Combine like terms here, I'm going to get 86. Subtract. And now I know the middle. So if I put that in, I can subtract 0.16 out of 49 and out of 37. And that leaves me with 33 plus 16 plus 21, which does equal 70. So I know that's true. It says let E be the event consisting of all outcomes in exactly one of the sets A, B, and C. So we would need only B, only C, and only A, which we don't know. Now we know 70% of this is in these two circles, so the question is, well, what's in these two? If you look back at your definition for a partition, there is nothing in the empty set, so we can assume the rest of that 30 is all inside of A. And your final answer is 84%. As we wind down to these last two problems, I would suggest that you, for number 11, do it on your own, and then pause the video to do that, and then hit play to see if you are correct. All right, let's see what you got. I've gone ahead and put in the information from the top here in red, blue, and green, and then it says no senior has all three, meaning cell phone, MP3 player, or laptop, but 25% have exactly two. And if you add these up, it's way over 100% because some of them have more than one. So as a senior is selected at random, find the probability that the senior chosen has none of these technologies. Now it does say that no senior has all three. It does not say if anyone has none of them. So in a picture, this is kind of hard to draw up. While we do know some of these regions, like we know 0 people have all three, we don't know these regions. We know 2, but we don't know, how to divvy up 25%. So if you can't label the whole picture, it does become quite a difficult problem to try to solve. What I would suggest is maybe using an extension of the formula we used 2 problems ago. And here's what my thinking is. If I can figure out this probability, which would be all of this, I could very easily figure out what's on the outside here, and that's the question I'm meant to answer. Who has none of these? So the way you use this probability is you're going to have to say A plus B plus C minus the overlap. Alright, well, we know A, we know B, we know C. Now the overlap between these exists in far more regions than just here. Okay, so we need to take this with a grain of salt and understand that that means here, here, here. Well, that's just going to be 25% plus 0. So 0.25, and we get 95. Therefore, if 95% is in here, that must mean 5% is out here. So our final answer is, 0, 5.